Okay, today we're going to talk about functions or the building blocks of mathematical models. Let's start with a couple terms. A function describes how a dependent variable changes with respect to one or more independent variables. When there are only two variables, they're often summarized as an ordered pair with the independent variable first. So you might see it as independent, comma, dependent, or what we like to think of as x, comma, y. Okay, the dependent variable is a function of the independent variable where x is the independent and y is the dependent. Often we refer to this as y equals f of x. So f of x is what we refer to as function notation. Okay, for each situation, express the given function in words. Write the two variables as an ordered pair and write the function with the notation y equals f of x. A, you are riding in a hot air balloon. As the balloon rises, the surrounding atmospheric pressure decreases, consequently causing your ears to pop. Okay, so what is going to be the independent? What's going to be the dependent? So, in looking at this, we've got two sort of quantities that are changing. As the balloon rises, so we've got height of the balloon, the atmosphere pressure decreases. So we've got these idea of height. So as height goes up, pressure goes down. Okay, so what would be our independent dependent? Well, the height is going to go up on its own. The pressure depends on how high up we are. So the height would be our independent, and the pressure would be our dependent for this case. So pressure would be a function of height. Okay, example B, you are on a large barge headed down south to Mississippi River. You notice the width of the river changes as you travel southward in the current. Okay, so we got width is changing, and current would be, let's see. Okay, so the second example, we have a barge headed south on the Mississippi River. We notice the width of the river changes as we travel southward from the current. So the river width depends on the distance we've traveled. So distance from the source of the river Okay, so in this case, the distance is the independent and the width is the dependent, because the width of the river depends on the distance we've traveled. So our width function would be a function in terms of d. Okay, when representing functions, there's a couple of ways that we could do it. We can, one, we can use a table. So we make a table of values, data table, sorry. Two, we can draw a picture graph. And three, we can write an equation or a formula of some kind. Okay, the domain of a function is a set of values that make both sense and are of interest in the independent variable. Those are related to the x values. The range of a function consists of values of the dependent variable that correspond to values in the domain. So we would say that that refers to the y values of our function. Okay, now with the number of hours of daylight varies with the seasons. Use the following data for 40 degrees north latitude to model the change in daylight hours with time. Okay, so we're going to be given some facts about the number of hours in a day, and we're going to represent this in a couple of different ways. Number one, the hours of daylight is the greatest in the summer solstice around June 21st, when there are about 14 hours of daylight. The number of hours of daylight is smallest in the winter solstice. This is when there's about 10 hours of daylight. And the spring and fall equinoxes, there are about 12 hours of daylight. Okay, so let's kind of think about some different ways that we can represent this. As time passes, the number of hours in daylight are going to change. So we're going to let T represent time and H represent hours of daylight. And so we can write a function that says that the hours of daylight are a function of time. Okay, and then what I want to do is I'm going to create a graph, and I'm going to label this information. Looks like I'm going to start in January, and then February, and then March, May, June, July, August, September, October, November, December. Okay, so I'm just going to label the 12 months of the year, and then I'm going to label the y-axis with numbers of hours. So it looks like the smallest we got was somewhere around 10. And then looked like we got in the middle we had 12 and then 14. And then I'm just going to plot some approximate points. Again, this is a rough sketch. Let's see, so in June we had 14 hours, so right there we had 14. Smallest in winter, December 21st, we had 10. Let's see, and then March and September, so March we had 12 and September we had 12. Okay, so we can kind of imagine the rest of this as we extend out this pattern, that it's going to keep sort of going back and forth and sort of bouncing up and down between these values. So in a given year, this would represent the number of hours of daylight in a year.